So this part is about Math 10-12 Foundational Mathematics, Fraction Part 2. Now, we've done with multiplication and division in the last video, so now we're doing addition and subtraction. And I know you might be thinking about why do we do that out of order? Because addition and subtraction are far more difficult than multiplication, even though when you do whole numbers, it's the other way around, right? So here's the thing. First, we have to kind of recall what is an LCM. Right? This is called a least common multiple. Now, to make it very simple for us, LCM is simply the number where where other numbers multiply into together. That's probably the easiest way to say it. So for example, right, the LCM between, let's say, 7 and 11 is 77. Why is it 77? Because 7 times 11 is 77. 11 times 7 is 77. So that's the easiest one. Here's another example. The LCM between, let's just say, 8 and, let's say 10 is, now, before you say 80, right, 8 times 10 is 80, right? That is not the least, right? Maybe I should say the smallest number, the least, right? The least level, right? The smallest number. 80 is a common multiple. But think about it, right? 8 times 5 is 40. 10 times 4 is also 40. So there's a small number that will work. So that's the key to this LCM thing. Which one's the smallest? Here's another example. The LCM between, say, 5 and 15 is 15. Because 5 times 3 is 15. 15 times 1 is 15. So basically, if the smaller number can go into the bigger number, then that big number is automatically the LCM. So here's another example. The LCM between, say, 2, 3, 5, 8, 10, and let's just say, let's say, 240. Then you're like, wait a minute, that's a lot of numbers, right? Well, here's the thing. Look at this. 2 can go in 240, right? Because it's even. Can 3 go in there? Yeah. 5, 8, 10. Everybody can go in 240. It's 240. Because every other numbers can divide evenly into 240. That's the key. I know it's, kind of weird, and I will never ask you this on the test. Just fact, right? The problem is, what happens when you have stuff like the LCM between, let's just say, 24 and 40? That's a big problem because 24 and 40, it's not very obvious, right? Which number they can go into. So here is the way to do it if you cannot recall that number immediately. Just go like this. 24. I'll just go 40 first. 40. And I just think about all the multiples of 40. So starting with 40 times 2 is 80, right? And then it's 120, right? And then 160. 160. And then, so I'll just keep N40 basically. 200, right? And then 240, right? And then 280, right? And then 320, right? Let's keep N40. So it's 40 times 2 times 3 times 4 times, just keep on multiplying. And I get 360, 400. And let me see. I think that's good enough, but I'll just do 440 just for the heck of it. Now, my next question is, can 24 divide evenly into any of these numbers. Now notice I used a big number. 40 is a bigger number, right? I just go ahead and list them all down. And then I look at 24. Can 24 go into any of these numbers? And now don't be shy about using a calculator because you're not supposed to do this in your head, right? So I would just go with, say, 80. 80 divided by 24 doesn't work. 120 divided by 24. Oh, turns out this guy works. You see this? 24 goes in there 5 times. So it turns out that 24 times 5 equals 120. So therefore 120 is the LCM. So, I did not have to list all the other numbers, but I used to list at least 10. Just to be safe, because I don't want to be doing both at the same time, right? So that's the LCM. So LCM's not too bad. You just gotta be be persistent about it. And just to show you one more example, what is the LCM between 15, 18, and 20? So 3 numbers, right? I would do the same thing. 20, what are the multiples? 40, 60, right? 80, 100, 120, 140, 160, 180, 200, 220. Right? So I'll just stop right here. Now my question is, what number can 15 go into? What number can 15 go into, and what number can 18 go into? That's the key. Now, you might have multiple numbers, but the key is which number can all 3 go into at the same time. So 15 got to go in, 18 got to go in. So let's try 18 first. And again, you can use a calculator, you can divide, and you can do, hey, 40 divided by 15, that's not going to work, but 60. Huh. 60 works. So we got that. 80 doesn't work. 100 doesn't work. Nope. But 120 is going to work. So 120, that works. And the next one's going to be 180. So you can try it out yourself if you want to. So those are the 3 numbers from the list that 15 can go into. Now the question is 18. What number can 18 go into? That's going to be a lot tougher because you can keep dividing and you will see that the only one, so you can try 60 divided by 18 or whatever, you can try all that, but you will see that the only one that's going to work is 180. And you can also just use these 3 numbers, right? And just divide these guys by 18, because after all, you're looking for a number that all 3 can go into. So all the other numbers got cut already. So only this guy, and this guy matters. Right? And then it turns out 15 go into those 3. 18 can only go to this last one here. So 180 is the LCM. This one is tough. Right? You got to actually think about it. You got to write it down. You got to check it out. So it's different than the other ones that we have. But why do we need to know LCM? Because addition. Addition of fraction requires LCM. So let me do an easy one first. So let's say we have, for example, let's just do something easy. 2 over 5 plus, let's just say 1 over 5, right? Easy one. It's exactly what you think it's going to be. You have 2 out of 5 pieces plus 1 out of 5 pieces. So together is, let me just do, I usually do like this. 2 plus 1 like this. So the numerator got put together, but the denominator stays the same. So 2 plus 1 is on the top, 2 plus 1 over 5. So that's equal to 3 over 5. Well, that's pretty simple, right? The problem is this. What if the bottom are not the same? What if the denominators does not agree with one another? So we got 2 over let's say 5 plus, let's just say 1 over 10. Now you get a problem. Now, please don't do this, right? Some people do this. They do 2 plus 1 is 3, 5 plus 10 is 15. No, don't do this, right? This is no multiplication. Multiplication, you can multiply straight up. Addition, you have to find what we call common denominator. So how do we do that? Well, remember in simplification, you can divide any number you want. It turns out you can do the opposite. You can multiply any numbers you want. You just have to multiply the same number on the top and the bottom. So what do I mean by that? So let me copy this right here. So 2 and 5. The question is, between 5 and 10, what is the LCM? Well, that's easy. 5 goes to the 10, right? 10 is the LCM. So I want the denominators to be 10. So I will do this. I will do 5 times 2. Because 5 times 2 is 10. And I'll do the same thing on the top. 2 times 2. So I now have 4 over 10 plus 1 over 10. And that, now we have the same denominators. Basically, you transform the 2/5 into 4/10, which is the same thing. Value-wise, the same thing. 2 pieces over 5 is the same thing as 4 out of 10. Imagine you're cutting a pizza, right? Instead of cutting into 8 pieces, you cut into 4 pieces. But you take 2 out of 4, or take 4 out of 8. It's the same thing. So this becomes 5 out of 10, right? But it's not over yet, right? 5 over 10 can be divided, can be simplified by 5. So that becomes 1 over 2. And that's the answer. So addition takes more work. Now, let me try another problem. So let's say we have, let's say 5 over 18 plus 1 over 15. Well, actually, let's do 2 over 50. And then minus 1 over 20. Right. So that's kind of the one that we talk about here in the last problem. So this one incorporates subtraction. So maybe I should go ahead and put subtraction here. So you understand addition and subtraction are the same thing, right? Just, it's more of the same, right? So now look at this. 18, 15, and 20, right? So here's what I would do. I know, based on this LCM thing that we just did, I know 180 is where I want to go. So I want, ultimately, the bottom, right, to be all 180 in some way. So let me copy all this. All right. So I need to do something so that it'll be 180 all throughout the entire, so it'll be like this. Let me see if I can delete that. Oh, there you go. So see that? So basically I need to do something to these guys. So it'll be 180 for all 3 of those fractions. So you're like, well, what do I do? Well, here, I can multiply. The question is, what do I multiply, right? So multiplication is, think about it, right? 18. 18 times what number is 180? Well, that's easy. 10, right? 10, right? If you multiply 10 at the bottom, you have to multiply 10 to the top. What about 15? Now, if you're ever confused, let's do this. 180 divided by 15 is 12. Right, so using calculator can help you on this one. So times 12 then. Times 12 times 12. Right? And this one's easy to 20. But 20 times 9 is 180, right? 2 times 9 is 18, right? So multiply by 9, right? Go up times 9. Like that. So then you get 5 times 10 is 50. 2 times, that's 24, right? 2 times 12. And then 1 times 9 is 9, like that. So you end up with this guy. You end up with plus 24 minus 9, like this. So that's equal to, let's say, 50 plus 24 is 74. 74 minus 9 is 65, right? So that's 65 over 180. And you're like, okay, well, that is cool and all, but I can do something about this, right? Yep, because they both end with 5. So you can say equal 65 divided by 180. They can both be divided by, let's see, I'm gonna do 5, right? So divide by 5. And that should give me, let me see, 5 goes in the top 13 times. Oh, and then the bottom was 180 divided by 5. That'll be 36. Like that. And that's the answer. So there's a lot of work on this one. Addition, subtraction are far more difficult. So just want to make sure everybody's cool with this one. So you will have questions on this. So just let me know. I can type up the solution. I can make another video specifically for your question if you want to. Just let me know, right? And so that's the end of this particular session. Thank you.